Hello, future engineers, subscribers, viewers, and students. Here is the solution to the quiz 5 about 2D equilibrium. It's been a long time that I realized that giving you the simplest problems in statics does not matter. I would rather give you challenging problems next time because I expected that most of you will perform well in this quiz, but still I'm disappointed. So expect challenging problems next time because there's no difference giving you the easiest batch of problems in statics and giving you moderate to challenging ones. I still expect the same results. So here's the solution. Determine the forces of AD, BE, and CF on the beam if it is in equilibrium. So take note that these members are two force bodies, so the line of action of each force would be directed along the axis of these two force bodies. So for AD, I assume it is upward or compression, BE tension down to the left to resist this X component of the 400 Newton force, and FCF, of course, because all of the loads are downward, so it's upward also. Obviously, summation forces X, because these two unknowns have no X components, as stated in the class, to inspire you with 2D equilibrium problems, identify first the unknowns, and since there are only three unknowns, it should be the motive, it should be your inspiration that you can solve this problem because there are three available equations of statics. And the first one can be solved directly if you sum up forces along x equals 0. So summation forces x equals 0, the x component of 400, 400 cosine 45, is equated to the x component of FBE, which is FBE cosine 60 degrees. So FBE is 565.7 newtons. Then, two unknowns left. Summation moment about C equals 0 allows us to solve for FAD. So clockwise positive, FAD, the total distance 0.9 plus 1.5, 2.4 plus 0.63, 3 plus 2.4, 5.4 plus 1.2, 6.6. So FAD 6.6. Then all these forces will have counterclockwise moment about C, beginning with the vertical component of FBE, the horizontal passes through C. So the vertical component of FBE is 565.7 sine of 60 degrees, and the moment arm is 3.6, plus the vertical component of 400 newtons, this 400 here, is going down. The horizontal passes through C also. Of course, there's no dimension given here, so it is negligible. So 400 sine of 45 degrees, moment arm 1.2, the vertical component, moment of the vertical component of this force, plus 400 times 4.2, 3.6 and 0.6, 4.2, then lastly plus 200 times 4.2 plus 1.5, 5.7. Solving for FAD, it is 745.9 newtons. And finally, summation of moments about A equals 0, this time counterclockwise positive. So counterclockwise moment equals clockwise moments. So FCF times 6.6, then equals, everything is clockwise, FBE sine 60, the vertical component, moment arm is 3, plus vertical component of 400, 400 sine 45 degrees, moment arm, because this is 3 plus 2.4, so 5.4, plus 400 times 2.4 plus 200 times 0.9. So FCF is 626.8 newtons. Then you check your answer. Summation versus y equals 0. So summation versus y equals, summation versus y should be 0 to validate these answers. FAD upward plus FCF 6 to 8.6 minus the vertical component of FBE 565.7 sine 60 minus the 200 here minus 400 minus the vertical component of 400, which is 400 sine 45. So it is almost 0. So okay. So that's it for this problem. It's very, very simple. And as I said, the easiest problem in 2D equilibrium. So another simple problem in 2D equilibrium. A 150-pound man stands on A, the middle rung of a 50-pound ladder. Then letter B, second part, 4 feet along the ladder from B as shown. Assuming that the floor and the wall are perfectly smooth and that slipping is prevented by a string DE, find the tension force in the string and also the reactions at the floor and at the wall. So the free body diagram would be this. So of course, if this is your body, it's like you will be compressed at A and at B. So that's why these forces are compressive forces. Then at D, this is a string. So of course, we expect that's tension. By principle of transmissibility of a force, for simplicity of the solution, you don't need to bother yourselves finding this distance. I move T along its line of action. I transfer it to E, and these are the components. Horizontal T cosine 30 degrees and the vertical T sine 30 degrees. So this is the FBD. There are 3 unknowns again. That should inspire you that this problem is very simple. In fact, if you sum up moment about the intersection between NB and NA at O, you can solve for T immediately. If you want to find the intersection between NB and T, which is somewhere here, then you can by trigonometry, but I will not recommend that, although that's also another solution because I transferred T here so that the distances would be preferably known. So the equation I established here is as simple as the 3 available equations of statics. That is, I'll make NA the first unknown, NB the second unknown, and T the third unknown. So summation forces X equals 0. There's no component of NA, 0. Then NB is to the left, so minus NB. T component is to the right, so plus T cosine 30 degrees, and no more. That's why it's 0. So this is the middle rung. That's why if this is 6 feet, that's 3 feet. That's also 3 feet, half of 6. And the total weight here would be the weight of the ladder, which is 50 pounds, plus the weight of the man, 150 pounds, so 200 pounds. Summation forces Y equals 0. NA is upward, positive. There's no Y component for NB, 0 NB. Then minus T sine 30 degrees. Then minus 200 equals 0. So transpose negative 200 to the right equals 200. So call that equation 2. Then lastly, the third is we sum up moments about E so that tension will not be involved and the equation will be simple. So summation moments about E equals 0, clockwise positive, NA times 6, then minus NB times 12, minus 200 times 3 equals 0. Simplifying, 6NA minus 12NB equals 600, equation 3. Using your calculator, solving equations 1, 2, and 3 simultaneously, these are the results. Then for part B, or for another way of solving for the tension by checking, if you sum up moments about O equals 0, we can solve for T right away just to validate also these answers. So that is counterclockwise positive. So we have T cosine 30 degrees times 12 and minus T sine 30 degrees times 6. NA and NB are not involved. Then minus 200 times 3 equals 0. Solving for t, it is also 81.17 pounds. For part B, this is now the man, 180 pounds, and that's 4 feet. Then let's solve for this distance by similar triangles. So for the big triangle, right triangle here, 6 as to hypotenuse, the hypotenuse is square root of 6 squared plus 12 squared equals xb. This is denoted xb as the hypotenuse 4 feet. Solving for xb, 1.789 feet. So having found xb, we can now set up again same equation, summation versus x equals 0, so 0 NA minus NB, 0 NA1 minus NB1, then plus T1 cosine 30 degrees equals 0, equation 4. Summation versus y equals 0, NA1 plus 0 NB1, then minus T1 sine 30 degrees minus 200 equals 0, 50 and 50, or equals 200, equation 5. And finally, summation moment about E again equals 0, NA1 times 6 minus 12 B1 times 12, then minus 50 times 3 minus 150 times 1.789 equals 0. Simplifying this constant, transpose to the right, so that sixth equation is 6NA1 minus 12NB1 equals 418.35. Call that equation 6 again with your calculator. Solving equations 4, 5, and 6 simultaneously give us NA1 252.9 pounds, NB1 91.57 pounds, and T1 105.7 pounds. You can solve for T1 again if you sum up moments about this point O again, or you introduce another point somewhere here, specify the distance so that all these answers are involved. Summation of moments there, the sum should be 0. So that's it for this video.